Most audiophiles will happily spend $10,000 on a flagship digital to analog converter, but then completely bottleneck its performance by plugging it directly into a $50 plastic router from their internet service provider. As an engineer who spent decades building out commercial-grade network infrastructure, I can tell you that standard routers prioritize bulk data delivery, completely ignoring the absolute timing and electrical silence required for high-resolution audio. If you do not physically isolate your audio equipment from your home network's electrical interface, you're actively injecting noise and jitter right into your DAC. Here's an even more detailed look at why you need a reference-level network gatekeeper, and why the Aurender NH10 is the ultimate hardware solution to this problem. To understand the necessity of an audiophile switch, we have to look at how data actually moves. Mike Gibbs, a brilliant network architect with 25 years of experience, explains that standard internet service provider design networks for generic access. A commodity ISP router is perfectly fine when losing a data packet, requesting again, and receiving it a second later. When you're loading an email or watching a buffered Netflix show, you never notice. But high-resolution music is real-time continuous data. If a data packet gets dropped or arrives out of order due to variations in latency, known as jitter, your audio quality suffers immediately. Standard routers lack the hardware to prioritize your dedicated audio streams and provide zero protection against network congestion or electrical noise bleeding into your Ethernet cables. Enter the Aurender NH10. At $4,300, the Aurender NH10 is effectively the Taj Mahal of audiophile network switches. While it is relatively a low-profile product, it delivers an enormous impact to any flagship streaming system. It is not flashy, but it is meticulously engineered with 3 core philosophies. The absolute foundation of why cheap big-box store network switches ruin audio quality is their power supplies. Most consumer-grade network equipment rely on switching power supplies, also known as AC to DC converters or wall warts. These power supplies operate by rapidly switching electrical current on and off thousands of times per second. While this makes them cheap, lightweight, and highly efficient to manufacture, this rapid switching inherently generates massive amounts of high-frequency electrical noise and ripple. If this noise is not properly shielded and filtered out, this high-frequency noise can bleed directly onto the internal circuitry, traveling down the highly conductive copper wires of your Ethernet cable and dump straight into your sensitive analog circuitry, such as your high-end DAC or streamer. The Aurender NH10 completely eliminates this issue. Every single circuit within the NH10 is powered exclusively by a pure linear power supply. Linear power supplies are fundamentally better for noise reduction because they deliver smooth, continuous power without relying on rapid electrical switching that generates high-frequency interference. Instead of rapidly switching current on and off, a linear power supply typically utilizes a large custom-wound transformer to step down the AC voltage from the wall outlet into a smooth and continuous manner. Because there's absolutely no high-frequency switching taking place, that specific type of electrical noise is never generated in the first place. This analog approach to voltage regulation results in exceptionally clean, whisper-quiet power delivery. You can visibly see the massive isolated red power transformer inside the chassis, ensuring power-related distortions are minimized before data ever reaches your streamer. Advanced linear power supply designs like the one found in the NH10 or the Matrix Audio SS1 Pro might also incorporate oversized toroidal transformers, fast Schottky diodes for quicker recovery time, and heavy audio-grade filtering capacitors and ultra-low noise or LDOs, low dropout regulators, to further regulate and purify the power. By providing completely clean power to every internal circuit, the linear power supply minimizes power-related distortions at the physical source and drastically lower the overall noise floor of the system before the digital data ever reaches your streamer. Standard Ethernet cables are constructed with twisted, highly conductive copper wires, meaning a cable running across your living room acts like a giant antenna that picks up electromagnetic interference from surrounding devices like Wi-Fi routers, televisions, and power cables. It can also carry ground loop noise straight from your home's electrical panel into your sensitive audio equipment. The NH10 acts as a physical quarantine zone. It features 6 filtered RJ45 Ethernet LAN ports and 2 optically isolated SFP fiber ports. Rather than hardwiring specific ports as strict inputs and outputs, the network switch differentiates them by their level of noise filtering. 2 of the RJ45 ports feature double filtering for use with your already filtered Aurender devices, while the remaining 4 RJ45 ports feature 7 times filtering for generic network equipment like routers and NAS drives. While high-end switches apply advanced physical filtering to purify the signal on standard copper Ethernet cables, the metal wire itself still provides a physical pathway for electricity to flow. For true 100% isolation, the NH10 features optically isolated SFP fiber ports. Because fiber optic cables transmit data using pulses of light rather than electrical currents and contain absolutely no metal or conductive materials, they create a complete electrical air gap. This physical separation completely severs the electrical coupling between your home network and your audio system. Since there is no conductive material spanning the gap, it becomes physically impossible for electrical noise, ground loops, or airborne electromagnetic interference to cross the barrier. This ensures your digital signal is completely immune to the electrical noise that commonly corrupts traditional copper cabling. Single-mode fiber specifically transmit data using a single light path through a very narrow core. This specific design allows it to transmit data with less signal distortion over much longer distances than multi-mode fiber, ensuring your digital signal remains perfectly intact. Furthermore, the unit is wrapped in a thick precision machined aluminum chassis. It weighs in at 17.6 pounds. This dampens the acoustic vibrations and acts as a massive shield against airborne interference. They even include a physical LED off toggle switch on the back to kill blinking light port activity indicators, eliminating the microscopic electrical pulses they generate. Clocking is critical in any transfer of digital data. Effective real-time communication, such as streaming high-resolution audio, relies on guaranteed low latencies and highly accurate time synchronization to ensure that distributed devices are perfectly in sync. The 2 biggest enemies are latency and jitter, microscopic variations in timing. Standard network traffic is fine with lost or delayed data, but high-resolution music is a rapid, continuous sequence of data packets. If network jitter causes these packets to arrive with microscopic timing discrepancies or out of order, your digital-to-analog converter is forced to guess and error correct. When the DAC mathematically guesses where data belongs, it introduces audible distortion, causing the 3-dimensional soundstage to collapse, imaging to smear, and the music to sound harsh and inherently digital. To solve these timing discrepancies, advanced networks utilize protocols like PTP, which stands for Precision Time Protocol, to establish a highly accurate master stratum clock. This clock acts as a central timekeeper, ensuring nanosecond level synchronization across devices. This drastically minimizes the jitter caused by different devices having mismatched time measurements. Beyond audiophile listening, this level of perfect synchronization is becoming mandatory in the broader tech world through time-sensitive networking, or TSN, for applications like operation technology networks, automated machines, and robotic systems. The NH10 completely reorganizes the timing of your digital stream using an ultra-stable OCXO, or oven-controlled crystal oscillator. And OCXO clocking is superior to standard quartz crystal clocks because the master crystal is physically placed inside a temperature-controlled oven, making it entirely immune to environmental drift and completely eliminating timing drift caused by temperature changes. Because of this thermal stability, the OCXO in the Aurender NH10 boasts a flawless frequency stability rating of less than 0.005 parts per million. Note the clock in this device runs at an average manufacturing cost of $800 to $900. Most of the competition are using much lower priced clocks. The Aurender NH10 uses an FPGA field programmable gate array for advanced synchronization of its internal operations. Specifically, the FPGA acts as a controller that ensures absolutely every internal process within the switch is perfectly aligned to the device's ultra-stable OCXO master clock. By locking all internal operations to the single flawless master heartbeat, the FPGA synchronization completely eliminates microscopic timing discrepancies and drastically reduces jitter before the digital audio data is handed off to your streamer. If you plan to use an external master clock, like say the Aurender NH10, you should couple this clock connection with a highly shielded 50-ohm digital cable such as our Black Dragon. So for that even greater performance, you can use an external master clock via the professional grade 10 MHz 50 ohm BNC master clock input on the rear panel. This connection allows you to completely bypass the internal OCXO clock and perfectly integrate the switch with a standalone ultra high-end external reference clock. Aurender designed this input to be 50 ohms to ensure impedance matching. Unifying the timing across your entire digital audio ecosystem in this way drastically reduces jitter. It preserves the music's three-dimensional imaging and adds a stunning lifelike realism to your system. As I've heard one user accurately describe it, putting the Aurender NH10 into your system is like upgrading your DAC, because you are lowering the noise floor and drastically reducing jitter before the signal ever hits your streamer. The improvement is striking. When you A/B test the NH10, removing it and putting it back in, you instantly hear a clarity that simply wasn't there before. The biggest impacts are found in vocals, pianos, and the upper octaves. There is a new naturalness and lifelike realism, incredible spacing around the instruments, and the bass becomes noticeably tighter and punchier. Even if you do not own an Aurender streamer, the NH10 can serve as an ultimate hub for any Ethernet or fiber-capable device in your system, including gear from DCS, Bricasti, or Esoteric. Just remember to pair it with high-quality shielded network cables like our Silver Dragon and Bronze Dragon to get every last drop of performance. If you want reference-level sound, start from the source. Clean up your Ethernet signal and let your ears decide. If this deep dive helped you understand the vital importance of the network in your audio signal chain, make sure to hit that subscribe button down below for more no-nonsense engineering advice. If this review made you rethink your own setup, you must watch my full conversation with Mike Gibbs. It's a natural conversation about networks and how they actually work with audio, featuring a few important tips and tricks for audiophiles to consider. Click the video on your screen and I'll see you there.